Greetings, esteemed panel members. I am Akhil, here to talk about our project, an IoT-based classroom environment with dynamic attendance monitoring and active power saving on behalf of my team members Akshay Vishwanathan, Bhavan Nayak and Atharva Moge. Here are the things we'll be outlining for this presentation. Starting off with the abstract, a gist of what we aim to do and the problem we aim to solve, a summary of requirements, the various approaches in design and what it requires for a successful implementation, the summary of the methodologies, and how exactly we aim to go solve what we intend to solve, a design description, modules and implementation details detailing the exact spec of the hardware being used, a project demonstration and walkthrough, a test plan and the strategic measures used to ensure the integrity and the accuracy of the system, and a deep analysis of the results of the said test plan to ensure a working system, the lessons learned from our experience, and conclusions and looking for any scope of future work regarding how we can better the system and what more issues we can aim to fix. Now, this would be our main problem statement is how we can primarily sort of create a solution for attendance and classroom power management. We aim to do this by developing an intelligent IoT-based environment with the primary objective of energy optimization and an intelligent as well as reliable attendance system that focuses on reducing latency, which and also focuses on the fact that it would be foolproof. The abstract and scope of our problem. For the longest of time, attendance has been taken manually. We would see teachers manually call out each names of the student, and you would see each and every student answer to their roll calls. And this is a tedious and a time-consuming process and has wasted useful class time. In addition to this, classroom equipment such as fans and lights, etc., have been left on regardless of the room being empty. Any kind of automation regarding attendance on a classroom level has always been prone to malpractice or failures, and our project aims to change this for the better. And in the meantime, we are also planning to sort of create an fully integrated energy conservation system, fully integrated onto our classroom attendance management system. And we're first planning to implement this in our own campus and then extend it to other institutions. So we've analyzed some pre-existing solutions and have drawn sufficient conclusions as to how our approach is better. So the first one of the more common things which we see regarding attendance would be face recognition. However, it's proven to be very problematic in a time-sensitive environment such as a classroom due to the fact that it has a considerable delay in scanning. Not to mention the performance hit on computation of facial recognition. Due to said factors, it lends into it not being a greater solution. We also have an outside singular fingerprint scanner, which would be a fingerprint scanner kept on a terminal outside the classroom. This seems to initially solve the delay issue. However, it leads to malpractices and is easily circumvented by students just scanning their fingerprint on the outside the classroom and then just leaving the classroom. Then you would have, as far as the energy conservation system is concerned, we would have a centralized AC/heater system which can replace fans altogether. However, this leads to the problem that it's a singular temperature for everyone in the entire floor. Not to mention the infrastructure cost of it would be quite high compared to manual fans. And the manual fans, they themselves are not automatic, leading to disruption in class. Now, here are the requirements which we have detailed in the solution which we plan to propose. We start off by having a small modular optical biometric sensor module. This is a TTL capacitive fingerprint scanner. Then we have spatial sensors to detect movement in the classroom, to check which part of the room is occupied, to make the system spatially aware. And the third aspect is our software component, which is a Windows software written and scripted in WPF. To make this would be the dashboard application for how our entire administrator and data management. Our design approach. So we would first have the assortment of IoT sensors which have been installed in the classroom, and this is proven to be a one-time solution. Like this setup would not call for much maintenance, and this extends to server installation too as well. The only problematic areas which we can see is the entire server backend system. However, if the institution does have a full-fledged server system, we can insource the entire backend system instead of outsourcing it to Firebase. This can also be able to cut costs. And thirdly, since we have a lot of data in our hands, we could run machine learning models for attendance summarization and fan speed detection as well, and we can sort of have turn this into a sort of like a system that learns from usage, thereby further reducing the need of any manual intervention. And in the future, we aim to have this system as a fully fledged learning model which learns from multiple classrooms and analyzes trends. Here are the design constraints, certain assumptions and dependencies which we've seen our system, which we've noticed. Firstly, the server systems and the institution. Our project currently highly depends upon how the server system exists at a particular institution. If there is no existing server, it would be quite easy to implement. However, if there is an existing server, we'd have to sort of configure it for our own databases. And secondly, the existing wiring in the institution also plays a part. We currently are using manual relays to cut power to the fans and lights, etc. And we need to edit. We'll have to sort of sit and change the current wiring system in order to implement our own solution into any classroom. Unless and this ideally would be quite easy, unless and until the system is very old. Now going into the design details, what sets our project apart. So firstly, the entire attendance system is completely automated, and the one thing which we've tackled is the fact that this system is completely foolproof. Considering we have new and innovative ways which students can use to sort of find a way to bypass attendance systems, we've sort of looked through and sort of found out a foolproof way to make sure the attendance is taken legitimately, and students find it quite hard to actually bypass the system. And as far as the energy conservation system goes, it's a completely full-fledged real-time implementation that is independent of the wiring system, and it may be extended to any sort of government schools or colleges in order to reduce their electricity costs. As long as the wirings would support a relay, our systems can be used anywhere. And this also comes under the entire energy conservation aspect of it, as it reduces the harmful effects of unsolicited energy consumption on the environment and saves the planet for future generations. So coming into each of the detailed modules, the first module would be the attendance system. The attendance system is taken electronically by means of a biometric optical fingerprint scanner. The way we've gone about sort of maintaining and the integrity and the security of the system is the fact that we've decided to go for a modular system, a small phone-sized module carried around by the teachers. So the idea is to first, as the teacher walks inside the classroom, she shuts the door, and as she decides to begin her lesson, she can sort of pass this fingerprint scanner among people once the classroom doors are shut. And this also ensures that there is no malpractices that's being followed, because as the doors are shut and the teacher has full control over the module, because this would be the personal module of the teachers, there is no scope of malpractices. No one from outside can actually enter without the teacher's supervision, and no one from inside can actually leave the class without the teacher noticing. So the entire attendance process will still have the teacher's full attention, just as how a manual attendance would be taken, however without any of the time constraints or without any of the time wasted. And the teacher can pass around or have each of the students scan the prints and register the attendance with absolutely no manual intervention. Now the second module would be the electricity optimization module. This involves various spatial sensors placed at the edges of classrooms, and the system will constantly check for any sort of movement or any sort of the presence of people inside the classroom. And the entire computation for this spatial awareness module is edge computed. You would have the fingerprint scanners, the microcontrollers on board the fingerprint scanners. They themselves are constantly computing for any of these movements, and this also extends towards the manual fans as well. Temperature monitors are basically installed, and as and when the temperature decreases, the fan speed is automatically increased. And if people move out of the classroom and the classroom is empty, after a sufficient time delay, all the devices have been turned off. This is the master class diagram for the entire system. Here you have different classes for different aspects and the different functions entailing each of the different classes. And this is the use case diagram. Here you have the teacher basically shares the sensor with each person of the class, each student of the classroom. Each of the students scans the fingerprints, marks the attendance, and then submits the sensor to the teacher. And while all of this is happening, you would have the system administrator basically overseeing the entire operation and reporting to the teacher. He would check the working of the sensor, ensures that the sensor would upload weekly attendance to the server asynchronously on a regular basis, and performs analysis and then submits it to the teacher's dashboard. This is a sequence diagram of how the sequence of events happens in the attendance module and in the electricity module. This is the packaging diagram as well. And this is the deployment diagram. And this is the deployment diagram for the electricity module. So here are the actual hardware details which the hardware products which we've used in each of the modules. For as far as the attendance system is concerned, we use a biometric sensor module which is capacitive. The reason we've opted for a capacitive sensor is because it ensures it ensures the integrity of each of the fingerprints being taken, and it also ensures that no matter how, if there's any, despite there being any pen marks or any sort of marks on the fingers, the attendance is being taken cleanly. And as far as our microcontroller is concerned, we use the ESP32 and an Arduino IDE as well for programming the ESP32. Then for the electricity optimization system, we have a manual setup for with spatial PIR sensors and an Arduino IDE to code set sensors with the microcontroller as well. And the third module would be the Windows application, which serves as a dashboard for the teachers. The front end is being coded with UWP or Universal Windows Platform, and the back end is handled by WPF or Windows Presentation Foundation. And as far as the hardware database is concerned, you would have MySQL for the database hosted over an XAMPP server. Currently, we've successfully been able to host it over a local network. So now let's go ahead and go through the walkthrough of the actual project. This is the automatic attendance module. This is so far the prototype of the entire fingerprint sensor connected to the ESP32. So the way this works is as and when you would sort of scan your finger, as you can see here, the fingerprint basically checks your fingerprint scanner, checks the print on your that's being scanned, and it automatically saves it onto the database, which is stored in the fingerprint scanner itself. And this goes on till the end of the class, and towards the end of the day, when pretty much all the classes are over, every single fingerprint scanner basically asynchronously uploads all the data to the final database one by one. This is done so that this avoids any discrepancies in the database after having multiple fingerprint scanners upload data at the same time. This is the second module, the electricity optimization module. As you can see, the PIR scanner is here, and if there is any movement detected here, the light bulb turns on. However, if there is no movement or if there's no object blocking the spatial sensors for a good 20 seconds, the light would automatically turn off. This is the back end. This is the console aspect of the electricity optimization module. As you can see, it keeps a log of when and what time the motion has been detected. And the third module is the Windows application. This is the alpha version of the Windows application without any UI enhancements. This serves as a dashboard for each of the teachers to sort of view and sort of analyze the data of every single classroom and their attendance data. And it also offers some additional functionality which I'll be detailing through. This is the actual dashboard once the teacher has logged in. Here would be a daily agenda of how many subjects she has for the day, and what subjects she has and on what time. Here, this option allows her to search each specific student details. She can search it with a student-specific roll number to see how many attendance the specific student, what the attendance of the specific student is, and how much marks the specific student has scored. This is the review daily attendance. It will give a gist of how many of the students, how many of the teacher students are attending her daily classes. This is the take extended period function. So a lot of teachers, they would, when they're devoid of time to finish the portions, they can they regularly sort of take extended period. This is a way to sort of keep track of the extended period functionality. The take extended period goes hand in hand with the marks for substitution. So let's just say if a teacher's finished the portion early, she doesn't want to take a specific class, she can click mark for substitution and then have her period be taken by any other teacher. So if a particular slot for the day is being marked for substitution, it is available for any of the teacher's dashboard for her to click on extended period. Once she clicks on extended period, she can take any other free slots to extend her said period. This is to edit the daily attendance sheet. For example, if a student was legitimately missed out on his or her attendance, or if they couldn't scan their fingers, if they couldn't scan the device properly in order to mark their attendance, a teacher can manually edit the said student's attendance to make sure that he still does get the attendance. And any such manual editing is sort of audited onto an audit log to make sure that it is overseen by the system administrator. The fourth module is our entire database management system. Here we have different tables, primarily concerning the input table, the output table, the period table, and the period number as well, and the student data concerning all the student details. So we have two main tables here, the input table and the output table. The input table is the table which intercepts the fingerprint scanner data. The input, we've separated this into two different tables so that we have one table that is external to the entire, external to any of the other tables which are actually being interacted by the fingerprint scanner. So each of the, as and when the fingerprint scanner detects a finger, it gets scanned and then it gets put onto the input table. And then there's an automated procedure which stored procedure which basically correlates this time to our period table and appends the student information and what period number he is and what subject he is and whether he is absent or present. And this output table is what is upon what we make each of our analysis. Now we come to the data visualization part. This is a part of the entire dashboard wherein we can, since we have so much data, we can sort of offer additional insights to the teacher as well. And here is where, so as sort of like a sample, we've taken a bunch of sample data and we've sort of performed a sample visualization and we've sort of done a trend analysis. And as a result, we can clearly observe that the CGPA of any student is directly proportional to the attendance percentage. Therefore, it basically goes to show that higher attendance shows that there is a chance of scoring higher CGPA. And that is it for our project. Thank you.